Hi, I'm Ike Ellis, and now we're going to look at migrating an on-premise SQL Server database to Azure SQL Database, another PAAS offering. So not managed instance, but now an actual Azure SQL database. And again, we're going to talk about how to do that in a scripted fashion in case you have hundreds of these little databases that you all need to migrate at one time. So we're going to look at how Azure SQL Database works, what makes it different. This is a true PAAS offering. It's not feature complete with a regular SQL Server on-premise, but we'll learn a lot about it. We'll look at deployment models, purchasing options, service tiers, serverless compute, hyperscale, some T-SQL differences, how high availability works. It's a lot different than always-on availability groups. We'll look at geo-replication, and then we'll take a look at how backup and restore works. That's also quite a bit different than how you do it in a VM or on-premise. We'll look at accelerated data recovery, which is a feature that exists in Azure SQL Database. And then finally, we'll look at security, bacpacs, and then a demo of how to script the migration. So Azure SQL Database was made, like I said earlier, in 2008, I think. So it's been about 11 or 12 years. It's quite one of the original services that Azure released. And it was designed to be a multi-tenant SQL database solution. So it doesn't look like a normal SQL server. And what you need to understand about Azure SQL Database is there's a difference between a logical server and a physical server. So for instance, when you create an Azure SQL Database, you create a logical server. The database exists on a logical server. That server doesn't actually exist. Instead, it's backed by nodes in a cluster that are physical, that do exist. And those nodes are created automatically, and they are automatically fault tolerant. So what that means is you'll have, by default, without ever specifying anything and without paying any extra, in fact, it's impossible to turn it off, you will have multiple physical copies of your database on multiple servers in different racks that can fail over and help each other out if one server goes down. And that's all local, and it happens for free. So even at the $5 range, even when you're like, give me a $5 Azure SQL database, you get fault tolerance. You don't have to set it up. You don't have to create it. You don't have to manage it. You don't even have to think about it. So can you imagine, for those of you who've set up availability groups, you know how much effort it takes to set one of those up. And you bypass all of that effort right out of the gate. So this notion of having a logical server, what happens is your application has a connection to a server, right? Just like a normal ADO.NET or Entity Framework connection. And when your application hits that server, it's not actually hitting a server. What it's doing is hitting a gateway. The gateway goes and finds the physical connection for the server that you want, and then it redirects your query to that server. This is how it achieves the magic of if one server goes down, it can fail over and get you to a different server, a different replica of your data that is strongly consistent, 100% consistent with no loss of transactions. This is also why it's critical that your application has retry logic in it, because if one of these failures happens, you're going to momentarily lose your connection. If you have retry logic to build the connection again, you'll just pick back up where you left off, with, out skipping a beat here. So when you deploy Azure SQL Database, you can either do it as a single database, which means each database is isolated from all the others and is portable, or you can deploy it to an elastic pool, which is a pool of databases that are grouped together. So here you can see, hey, I'm going to create a small elastic pool or a big elastic pool or a much larger elastic pool. These large elastic pools allow me to specify how many DTUs, I'll explain that in one more slide, how many DTUs are shared across all of these databases. So if I deploy as a single database, I specify the DTUs for only that individual database. If I deploy to an elastic pool, I specify the DTUs that are shared among the entire set of databases. So when would you want to use one over the other? Well, if you only have one database, just use a single database. If you have a bunch of databases and you know their load, you know what they need, then you don't need Elastic Pool. But if you have a whole bunch of databases and you're not sure what they need, but they seem to have load patterns that complement each other, meaning some are used during the day, some are at night, they never seem to be really busy at the same time, then you might really want to consider using Elastic Pool. When we purchase Azure SQL Database, we can either purchase a dedicated vCore and memory allocation, or we can purchase DTUs. So a vCore says that you choose the exact amount of compute resources that you need, and those are always available to you. Even if you're not using them, they're available to you. A DTU is a bundled compute and storage package that is usually a balanced package for common workloads. It's usually cheaper, and it's only available with Azure SQL Database, not managed instance, where vCore is the only thing you can license in a managed instance. There are two different service tiers. Similar to managed instance, Azure SQL Database also has two different tiers, general purpose and business critical. What are the benefits and advantages? Well, business critical, just like managed instance, has those super fast local SSDs. Those local SSDs provide a lot more IOPS and a lot more throughput and a lot more interactive response with the data for your users. You also get better log throughput. Now, let's stop right there. Log throughput and log contention is a critical issue in SQL Server and Azure. And if you're in a high load system with a lot of concurrency, or you're doing things use the log a lot, like a lot of data modifications and index updates and things like that, like a ton of inserts or batch inserts, right? You are going to use the log a lot. If you do that, here I'll give you an example. We're doing data loading pipelines using Spark and the SQL bulk copy API. General purpose. So Spark, what it does is it parallelizes these data pipelines across multiple nodes. So you can have like 10, 15 nodes create inserts feeding in a SQL database. General purpose will not keep up with that because of log weights. So we had to move to business critical. We could even make business critical slow down. We couldn't make Hyperscale slow down. So I'll tell you about Hyperscale in 2 more slides and you'll see the benefit of Hyperscale. Finally, business critical also has 1 read-only replica built in. You can have 4 using georeplication, but so can general purpose. So by default, you get 1 read-only replica, and read-onlys, remember when we talked about the last video, if you get the reads off of the primary, that is like a go fast button. You will see huge performance gains when you do that. Serverless. So we talked about this earlier in the first video, but I wanted to remind you of it. So serverless is an Azure SQL database that's basically deployed in a Docker container, and it's deployed as needed, meaning you use the compute, the thing spins up, it's being used. Your load pattern is intermittent, meaning sometimes it spikes, sometimes it shrinks. It spikes and shrinks with your load pattern. So let's say that you need 1,000 DTUs, boop, it bumps up. You need 100 DTUs, boop, it bumps down, right? If you don't use it at all, it will auto pause and it will stop billing you, so you don't get charged for it. Now, this all sounds magical, right? What's the drawback? Well, the drawback is if it does pause, when it comes to spin back up, it takes a few minutes. The other drawback is if you have a predictable usage pattern, it is more expensive than if you just get a dedicated capacity like a vCore. It's good for single databases with intermittent, unpredictable usage patterns. It's good for new databases where you just don't know the usage pattern and you're trying to figure it out. Once you figure it out, you could move to like a dedicated capacity. That brings us to Hyperscale. So remember my story where we were doing Spark data pipelines and they were super fast, super fast, super fast, and then they'd hit the SQL database destination and crawl to a halt. And we could never figure it out until we figured out it was log contention. Once we figured that out, we thought we'd move to Azure SQL Database Hyperscale, which I'll explain what that is in just a second. When we moved to it, it was very difficult for us to see any blocking performance problems with Hyperscale. We had to hammer the heck out of it with hundreds of concurrent data loads at the same time and gigs of data. And even then, it was hard for us to see where the performance problem was. So around our shop at Soliance, whenever we have a performance issue related to Azure SQL Database, we kind of joke about it, but it's kind of true. The solution is always, well, let's just switch to Hyperscale. And we switch to Hyperscale, and it tends to take care of it. If you go to the Azure portal and you learn more about Hyperscale, you'll see that it's not even that much more expensive. In fact, it's hard to even see the price difference all that much at all. So you really get a lot for your money, in my opinion. Now, what makes Hyperscale so magical? A couple of things. The first thing is they scaled the compute away from the storage. So I don't know if you ever took a SQL Server course before when you were new in your career, but in that course, they'll tell you that SQL Server, the engine of SQL Server, is divided into two parts. It's divided into what they call the execution engine, and it's divided into the storage engine. Now, what it looks like to me, and I'm not a Microsoft employee, what it looks like to me is they separated the execution engine and they call that compute nodes, and they scale those compute nodes separately. And then they separated that from the storage engine, which they call page servers, and they scale those things separately. And so somehow they have these local SSD caches that they put around it that makes the reads super, super quick. And then they also divided up the log so that it's not just a single log file, and instead it's a log service hosted on Azure Premium Storage. That log service, whatever black magic they have down there, completely gets rid of the log contention we were seeing in the other products. So they do this because they can now scale the compute separately from how they scale the log service, separately from how they scale the page servers. And it works miracles. So if you have any performance problems related to landing data in SQL, try out Hyperscale. It's way more affordable than like Synapse when you do like Azure SQL DB, SQL pools and things like that in Synapse. This seems to be a lot more affordable of an implementation, and really, really good. Okay. So there are some T-SQL differences that are getting lower and lower as the days go on. Rather than creating a slide, I always have to update. I just linked to the docs where you can see the T-SQL differences. So with Azure, let's switch back to Azure SQL Database. We're away from Hyperscale, right? And those T-SQL differences that I just linked to you, that's related to all of Azure SQL Database, not just Hyperscale. So also, Hyperscale is not just Azure SQL Database. Hyperscale also has an offering for Azure SQL Database Managed Instance also. So it's available for both products. So in Azure SQL Database, general purpose, this is our high availability option. And what you'll notice, I want you to notice a couple things here. One is you basically have a node, like a primary and some secondaries. And these gateways are separate in a control ring. So the application hits the gateway and then it gets connected to the right node, right? And then the data and log files are stored in a storage account. So Azure Premium Storage for the data and log, they're stored separately. And since both of these nodes have access to the same storage account, you have fault tolerance, right? And you have transactional consistency. So that's how general purpose is designed. Now, this will make more sense why business critical is more expensive, because here, each VM has their own SSD that's local to it. Those SSDs hold the local data and log. So the primary is just a node with local storage, not hosted in a different storage account. And the primary replica and secondary replicas each have their own data files and it uses availability groups to keep those databases consistent with each other. Azure manages all of this for you. You don't have to think about it. You don't have to set it up. All you have to do is just pay for it when you want to use it. We also have geo-replication. Geo-replication allows us to have those exact same replicas. By the way, this works for both general purpose and business critical. So you can have those exact same fault-tolerant architecture, but spread across multiple regions. So you can link the US West and US East, right? Or you can put one in Europe or Asia or whatever you need, right? Australia, right? And if you want to implement geo-replication with this service, it's just clicking a button. You just click on the map, which one you want, and boom, you've got it. So it really is pretty easy. We get automatic backups and restores, just like with managed instance. So we have full backups every week, just like with managed instance. We have differentials every 12 to 24 hours. We have transaction log backups every 5 to 10 minutes. We also have point-in-time restore, just like before. We can retain enough backups for point-in-time restore every 5 or 10 minutes for 7 days by default, but that can be changed up to 35 days. You also can configure long-term retention in Azure SQL Database, and you can keep up to 10 years of full backups if your audit compliance requires that. So many companies say, oh, you've got to keep your backups for 7 years or something, or you're out of compliance. Azure SQL Database and Managed Instance will both let you preserve your long-term full backups for that purpose, which is pretty neat. It's only for compliance, right? When's the last time you needed a full backup? Like, maybe you get a full backup because something bad happened 2 or 3 days ago, but have you ever pulled a full backup from a year ago to see what was in it? Maybe once in a while, but that you just don't need to do that all that often. So this is an Azure SQL server with some Azure SQL databases down here. You can see sales and SQL bits test Ike down here on my SQL server, right? And over here on the left, you can see that I have the ability to manage backups. So if I click Manage Backups, right here, I can pick which database that I want to manage, and I can configure retention. When I do that, this is the point-in-time restore configuration. I can choose to keep more differentials and logs so that I can do point-in-time restore further back. Now, I personally feel like 7 days is enough. But if you don't feel that way and you want more, the only thing you're paying for are storage costs, which really aren't that expensive. Now, I can also change my long-term retention configuration. For instance, if I'm supposed to keep yearly backups on week 1 for, let's say that we're supposed to keep them for 5 years, now I'm going to keep 5 full backups on week 1 for 5 years. And I can choose monthly long-term retention backups or weekly if I need to, and I can retain those for as long as I need to retain them, up to 10 years. So that is a huge and easy benefit for Azure SQL Database and MI, right? It's much harder to do that in a VM, right? You have to write all these scripts to manage the space, and they fail all the time. Here, it's all done for you, right? Okay. The other thing that I can do is I can go into, if I go into a specific database like sales, right? And if I want to make this thing geo-replicatable, remember I told you, hey, you can just come in here and just, hey, I want to make a replica there. And it just makes the replica. I can make a replica in Canada if I want, right? Or anywhere I want, right? Look at all the options I have. Now you pay for that. Every time you make a replica, you're basically doubling your cost. So you pay for that. But it's just one checkbox and boom, you're replicating around the world if you need to. Pretty powerful. Azure SQL Database has a feature called Accelerated Database Recovery. What this allows you to remember, with you do normal transaction log recovery, the server goes down. When the server comes back, let's say it goes down unexpectedly, right? Like an emergency. When the server comes back up, it has to look in the transaction logs for uncommitted transactions and roll them back. It has to look for committed transactions that have not been checkpointed and roll them forward. And then any committed transactions that have been checkpointed, it does nothing with, right? Well, that process took a long time. So if a server went down unexpectedly, it would come back up. It would be down for however long it had to down to go through that process, and people complained about it. In Azure SQL Database, we don't suffer from that because of this feature, because of ADR. So we get fast and consistent database recovery. Long-running transactions do not impact the overall recovery time. And the recovery happens irrespective of how many active transactions that we have to roll forward or roll back, right? We get instantaneous transaction rollback, and the reason why we get that is because of aggressive log truncation. Now that's one of the reasons, but we also have this thing called the S-log. What is the S-log? Actually, let's define that first. The S-log is an in-memory log stream. Sounds kind of similar to Hyperscale, really, but I'm not sure if that's true. It's low volume, and it's in memory. It's persisted on disk by being serialized during the checkpoint process. It's periodically truncated as transactions commit, and it accelerates the redo and undo process. So if you come back here, this is a typical recovery phase, right? But because of the S-log, it being in memory, this happens much, much faster than it does on premise. In addition, we have some security features that are not implemented on premise. Or maybe they are implemented, but you either have to implement it by hand or do extra things for it. But these things, you don't have to do anything extra. It's just a checkbox and it's good to go, or it's enabled by default. For instance, threat detection. Threat detection is Azure SQL Database's ability to detect when SQL injection events are happening. So remember little Bobby tables where, hey, somebody's taking malicious code and they're injecting it into like the name field of an input box on a website, right? Azure SQL Database will detect that's happening. It won't stop it, but it will alert you that it's happening so you can decide what you want to do about it. TLS is SSL, but for SQL Server, it allows us to encrypt the full transaction from the application over the wire. That's called encryption in flight. TLS, did I say TSL earlier? I'm going crazy. TLS is disabled by default on on-premise SQL servers, but in Azure SQL Database, it's enabled by default. In fact, you can't even turn it off. TDE, transparent data encryption. That is encryption at rest for both your backups and for your MDF files, your actual data files. That is turned on in Azure SQL Database. You can't turn it off. Where with on-premise, you do have to turn that on and get a certificate and do all the work to get that going, right? You get integration with Azure Key Vault. Always Encrypted works with it. Dynamic data masking works with it. Data discovery and classification work with it. Data discovery and classification is a cool feature that will help you identify PII, personal identifiable information, that you might need to do something with, like encrypt it or do something with it at rest, more than just TDE. You might have to actually encrypt the values in the column or use always encrypted to make sure it's encrypted both at rest and in flight, right? Now, we can migrate Azure SQL Database using the same service that you saw in the last video. We can also use the data migration assistant that you saw in like video 2 or 3, right, earlier. And I could show you those again, and those things would work. You cannot back up and restore. You can back up and restore to a VM. You can back up and restore to MI, but you can't back up and restore to just Azure SQL Database. So those other things work. And if you have a few databases that are all different, use those other things. It's graphical, it's easy, does the assessment. You saw how all that worked already. What I want to do differently here is show you how you can script a backup and restore using a bacpac file. And the reason why I want to show you that is, imagine that you are a software company and you have 300 hospitals that are your customers. And because you're in healthcare, each one of those hospitals gets its very own database. So you have 300 databases that are all exactly the same. they're all identical. So you know each database is in the exact same state. It just has different data in it because it's one database per hospital. It's multi-tenant, right? So what you can do is script it. And when you've got something that's identical like that, you get an awful lot of lift by scripting it. So the way we script it is by using a bacpac backup and then restore into the destination, and that works with Azure SQL Database. Okay, so up here you'll see a workflow diagram for things that you should do in order to do a proper migration. We've talked about these things a lot, so I don't see the need to go over this again. But I put it here for, just your reference if you need to go back to it. Before you migrate, you should know that there are some features that are not compatible. In addition to those T-SQL things that are not compatible, there are features like Service Broker and the CLR that you will not get in Azure SQL Database. There's some behavioral compatibility also. It just behaves differently. The way we already showed you how it does high availability and backup and connectivity. But remember, the most important thing it does differently is the retry logic, which it does tend to do, by the way. I've written many applications on Azure SQL Database, and that you have to have retry logic because it will end your connection, here and there. I mean, not every day, but regularly it will end the connection pretty abruptly. And if your application isn't graceful about handling that, the users just get error messages all the time. Not all the time, that's an exaggeration, but frequently enough it irritates them. So make sure you have the retry logic. We should test the migration and test the applications in Azure SQL Database because we don't have feature parity from on-premise SQL Server to Azure SQL Database. It's really important that we test, just test all the time. You can use the DMA assessment to give you some things. You can also try to extract your bacpac or DACpac into an SSDT project in Visual Studio, and you can try to compile it. If it compiles while you point it to Azure SQL Database, you're in really good shape. But if it doesn't compile, you need to resolve those reasons why it's not compiling. So we're trying to figure out where the disconnect is in the features that we've implemented as early and as often as possible during migration. There's some weird migration size limits here with the bacpac file. First of all, when you go to create a bacpac, you need to have the disk space free for it, and that can be a challenge. The file really has a hard time being higher than 400 gigs, so this wouldn't be a very good thing for really large databases. As you go to upload your file into Azure Blob Storage so that you can import it into Azure SQL Database, Azure Blob Storage has a block blob max of 4 terabytes. So that's hard to deal with also. So my point is, I don't think you can script really large databases going into Azure SQL Database. I really think that the sweet spot is somewhere around 10 megs to all the way up to like 10 gigs. But if you go higher than that, it's slow, it's buggy, it requires a lot of troubleshooting, and maybe you're just better off doing those really large databases by hand. Here are the migration steps that we've already covered, but I put these detailed steps here just so that you have them as reference. So these migration steps are just for the migration. It's not talking about setting up ExpressRoute or all the other stuff we've talked about before, right? So you provision your Azure resources. With a bacpac, you need some downtime because bacpacs are not transactionally consistent. So you need to stop having writes happen in the application. So make the database read-only, start the downtime, export the bacpac, upload it to Azure Blob Storage, start and monitor the import process into Azure SQL Database. Once it's completed, verify the objects and data, then grant database access, verify the application's working, and then declare the end of the downtime. So you can imagine how to do most of that, but if you want to know how to export the bacpac, this is the syntax for doing that. And like I said, it's not transactionally consistent, so you need downtime to do this. So if you're going to script, unfortunately, you're going to have some downtime in front of you. If you want to upload it, people have found good luck uploading it with AZ Copy. AZ Copy is an Azure copy utility for moving data around from on-premise to Azure. This is the syntax for getting it into blob storage. If you want to import it from blob storage into an Azure SQL database, the syntax looks like this. You can also use the bacpac in the portal. If you don't want to script it, you can do it by hand. That's totally legitimate. And then verify the data. This query will show you all the user objects in the Azure SQL database. This query will show you the row count. Now that you've verified it, you're good to go, and you've done a successful migration and you've scripted it out. Okay, so the first thing we do is we create the bacpac file by extracting it from a local on-premise SQL Server database. That command looks like this. So you have to first download DACFX, which is, or SQL package. Just if you Google SQL package.exe, you'll get a Microsoft download page. So you download that. You go to the path where it exists, which is in Microsoft SQL Server 150 DAC bin, right? And then you just say SQL package, a export from the local host. The source database name is T-SQL version 5. Put it on the D drive in the temp folder, and then create the bacpac file. And we do that real quick. And then when we move over to that D drive under temp, if we go to dir, you can see that T-SQL version 5.bacpac is there. Now the next thing that we need to do is AZ copy that bacpac file up to the Windows blob storage. And I'm using a shared access token, which I'll delete when this video is over. So now I hit enter there, and it uploads. Actually, it didn't work. Let me try to fix that command for a second. Okay, I solved that command. It was a problem with my shared access signature, which I'm going to circle back and show you how to do that in just a second. But the command looks like this. It's AZ copy the bacpac file, and then the Azure blob storage path with the shared access token, and I click enter, and it uploads it. Okay, we can verify that by going into Azure, taking a look at the storage account, looking in the containers and backup, and now you can see that T-SQL version 5.bacpac file, the one that you just watched me create. A quick word about shared access signatures. If I click here, this is the actual storage account here. And under storage account, if I go to shared access signatures, I can create a shared access signature here. You want to be able to interact with the container and an object, and actually the service is fine. Create a start and end date for when that shared access token expires, and then allowed IP addresses. You don't really want to do this in the real world, but this is what it looks like if you allow all IP addresses access to this. When you say generate a SAS token, you get a bunch of things generated here, but pay attention to the SAS token here, the question mark. See how it says question mark SV 2019? If you copy that and go back to that AZ copy command, that's what's after the question mark here. So you just like whatever is in there, make that the question mark here, click enter, and AZ copy will copy that all up to Azure Blob Storage. Now this next part is tricky because I don't want to show you my password. So what I'm going to do is show you basically a bastardized version of the command. Well, it's the same SQL package command that I showed you in the slides. I'm just going to go ahead and kick it off right now. And then once I kick it off, it's going to go, and I'm going to kind of scroll down past the command a little bit so you can't see my password. And what you can see is this thing is initializing deployment. It will start feeding tables in underneath it, and now that is taking the bacpac file and getting it into Azure Blob Storage. Okay, this takes a while though. It takes like 5 minutes, so rather than run this for 5 minutes, I'm going to pause the video and let it finish. Okay, and it worked. And now you can see sales V2, and we open up the tables, and you can see all the tables there, and you can see all the data. We can verify that there's data in here. Just run a couple quick queries. Yep, there's data in there, and we did a fully successful migration from on-premise to Azure SQL Database, all scripted, and now you know how you can script 100 of those things if you have to. That's it. We're done with that. Let's move on to some post-migration tasks.